Welcome to this video on Redox for A-level chemistry students. When we first started to create this video, we didn't realize how long it was going to be. So this is created in two parts. This is the first part. Thanks for watching. We're going to start off by writing half equations that identify the oxidation and reduction processes in a redox reaction. Let's take a look at this question. In a redox reaction, sulfur can form sulfur dioxide and nitric acid can form nitrogen dioxide. Write the half equations for the oxidation and reduction processes. Well, first of all, I'm going to write out the sulfur, and we know that that goes to sulfur dioxide. Sulfur dioxide is SO2. And I'm also going to, we've got nitric acid, and we should remember from earlier chemistry that nitric acid is HNO3, and we know that this will form nitrogen dioxide, which is of course NO2. We now work out the oxidation states. Well, let's start with sulfur. Sulfur's oxidation state is 0 because it's an element. So all elements have the oxidation state of 0. The oxidation state of the sulfur here will depend upon the oxygen. Now, oxygen almost always has an oxidation state of -2. So this is -4 because we have two of the oxygens. So that means sulfur would be +4. So if you have a molecule, the overall molecule must the overall oxidation state of the molecule must equal 0. So that's why sulfur is +4, because the two oxygens make -4 and the overall oxidation state of the molecule must be 0. Okay, let's work out the oxidation state of nitrogen in this case. We can see here that we have 3 oxygens, so that's going to be -6. And we know that hydrogen is +1. So that means that hydrogen will be +5. Again, nitric acid is a molecule, and so its overall oxidation state must be 0, thus making nitrogen have an oxidation state of +5. If we now look at nitrogen dioxide, we can see here O2 again has an oxidation state of -4, thus nitrogen must have an oxidation state of +4. What does this tell us? Well, this tells me that the oxidation state of sulfur has increased. So that would tell me that the sulfur is oxidized. Or we could call it the reducing agent. And that tells me that the nitrogen, well, we can see that the nitrogen's oxidation state is reduced. So, but we also know it's reduced because we know that we're doing this right, because if the sulfur has been oxidized, the nitrogen must be reduced. And we can confirm that by looking at the oxidation state of nitrogen, which goes from +5 to +4. So nitrogen is reduced, or we can describe this as the oxidizing agent. What I also want to do is I want to write half equations for each of the processes. So the first thing we will do is to write balanced half equations. The first step will be to balance up the sulfurs. So sulfurs are balanced. We have one sulfur on the left-hand side, one sulfur on the right-hand side, so that's okay. The next thing we do is we balance the oxygens, and we balance the oxygens by adding water. So I need to add 2 molecules of water. And the reason I need to add 2 molecules of water is because I have 2 oxygens here. Okay. And then to balance, now you can see that I've got on the left-hand side, okay, yes, I've got 2 oxygens, and on the right-hand side, I've got 2 oxygens. but I've now got extra hydrogens. So to balance up the hydrogens, I have 4 hydrogens on the left-hand side. You can see those there. So I balance up hydrogens by adding in hydrogen ions, and I need to add in 4 hydrogen ions. Okay, now finally I need to balance charge. So I have created a charge of +4 here on the right hand side, so I need to balance that out, and you can see that the charge on the left hand side is 0, so I need to add 4 electrons. We balance charge by adding electrons, so I add 4 electrons to the right hand side, and there I have my balanced half equation for the oxidation of sulfur to sulfur dioxide. Now I'm going to do the same with the nitric acid to nitrogen dioxide. So first of all, we can see that the nitrogens are balanced. That's good. Now we are going to balance out the oxygens. I have 3 oxygens on the left hand side and I have 2 oxygens on the right hand side. So I need to add 1 water to the right hand side, which is fine. Now I need to balance out the hydrogen ions. Okay, so we can see on the left hand side I have 1 hydrogen, and then on the right hand side I have 2 hydrogens. So I'm going to add 1 hydrogen ion here, and then finally I need to balance the charge, and I'm going to do that by adding an electron to the left hand side. And here we have our 2 balanced half equations for the oxidation and reduction processes. Thank you for watching this video on redox reactions, part 1. Part 2 will start shortly. If you've enjoyed this video, please like and subscribe below.